Professor Prakash Rogde, dealing with the subject information storage and retrieval for BIT class. So first of all, what is information? Information is made up from meaningful data. Data is nothing but the fact and figure. Ram, Sham, Sita, Gita, pen, pencil. This is called as data. And when data is having some meaning, it is called as information. For example, Ram is an intelligent student. This is the more information about Ram. So it is called as information. Second is storage. Now we have to store the information. In the old days, we were storing the information on notebook, on books, in books, or in many media. But nowadays, your hard disk drive and many more media, electronic media are available for storing the information. And second, last one is the retrieval. Retrieval is the process of searching, browsing and downloading. First of all, we have to browse, then we have to search the information of our interest, and then we have to download the information of our interest. So this is the meaning of information storage and retrieval. The very first point we are going to see is the IR block diagram. This is IR block diagram in which input document is the input, query is also one of the input. This input document and query, this query will act on the input document, searching through this system, and output will be generated. From this output, this is the feedback given to the query. So it is nothing but the feedback. It's a feedback. So output is fed as feedback to the query. So the query will be improved, and with the improved query, we are getting again the output. So we all have experience in Google search engine. When you are firing the query through Google search engine, it is giving you that. Did you mean that? It means that it is giving you the feedback for your fired query. So input document is also one of the input, query is also one of the input. System will process this input document with the query, and output will be generated. This is a simple block diagram of information retrieval. Now the next point is conflation algorithm. Document is not stored as it is on the web. Even we are firing the query, the whole query is not matched as it is with the input documents. First of all, the query representation will be generated, and the document representation is generated by the search engine itself every time. So this document representation is being generated time to time by these search engine algorithms. Here, our conflation algorithm is one of the good algorithm for making the document representation. There are 3 steps of this conflation algorithm. 3 steps. The very first step is remove common words. Remove common words. Now, which are the common words? A, and, the, this, that, shall, will, and many more. Likewise, your full stop is also a common word. Your parenthesis is a common word. Semicolon is a common word. So these words are not playing any important role in searching. So we have to omit or delete these common words. So common words are a, and, the, shall, likewise full stop, semicolon, colon, parenthesis. These are not playing any important role in searching, so we are removing it. This is the first step in the conflation algorithm. Second step is suffix stripping. Suffix stripping. What is suffix? A group of words or bunch of words coming after a main word is nothing but the suffix. For example, go is a main word. Then when we add suffix to it, it becomes going. So go is main word and ing is the suffix. Likewise, there are many suffixes. For example, we can say here ed, ny, yes, ews, ing. These are some of the suffixes which may be used in English language. These suffixes are not playing any important role in searching. Always we need a main word for searching. So by removing this ed, ly, s, ews, ss, ing, likewise suffixes, we have to find out the main word. And the final step in the conflation algorithm is root stemming. So I will write here, it is root stemming. What is root stemming? The words which are having common pronunciation. I repeat, the words which are having same or common pronunciation will be treated as same. For example, no, no, and KNOW, no. These two have the common pronunciation as no. So these two will be replaced by a single one. Now here, person to person, he will use another techniques or different techniques. If anybody is using the technique that if the frequency of this one is more than this one, then all these no will be replaced by no. Or one may use the technique, if this is coming first, this is next or second, then all those will be replaced by this coming first. So which technique we are using for replacing the common pronunciation word, it depends upon the person which technique he is using. So root stemming is the third step. So punctual, we must be very punctual and actual. Second, no's, KNOW no and no. Likewise, we can say full, FULL full, FOO full. So these two words are also treated as same words as they are pronunciated with same pronunciation. I will take one example which is appeared many times in the final examination or end sem examination, and it is asked to solve it by conflation algorithm. Now what is that example? Example is like this: herein, hereupon, herewith, hereafter. These are the four words given to us in the question and asked that solve this by using conflation algorithm. So here what we'll do, we will apply conflation algorithm on this example. First step, remove common words. Is there any common word here? Herein, hereupon, herewith, hereafter, no common word. So we can say remove common word is the first step, remove common words. In the below list, herein, hereupon, herewith, hereafter, there is not a single word common. So output will be as it is, here, in, here, upon, here, with, and here, after. Second step is suffix stripping. Suffix stripping. Now see, here this is the output of the first step. Which are the suffixes? In is a suffix. Upon, upon is a suffix. With, with is a suffix. After, after is a suffix. So these suffixes we are removing. So final output of our suffix stripping will be here, second time again here, third time again here, and last time again here. So all four times we are getting here, 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 here as the output of our suffix stripping. Now the final step or third step is root stemming. Root stemming. What root stemming says? It says that the words having common pronunciation will be treated as same. Now here, this pronunciated as here, this one as here, this one is here, and this last one is also as here. So all four words are pronunciated as here. So we are replacing all those four heres by a single here. Now the output of the final step, root stemming, is HERE. So finally, we can say that whatever the example given to us herein, hereupon, herewith, hereafter, the final output of conflation algorithm is HERE. So thank you everybody.